Hi, if you're here again, maybe God has give you wisdom, maybe from your family, maybe from your friends, or might any outsider. Okay, what I want to do today is we're gonna learn some basic about diode. We'll learn some basic about diodes, and we do some little experiment for the diodes. Okay, without further ado, let's get started. Several type of diode we will cover in this video. There are three which we started with: PN junction diode or rectifier diode, and the symbol just look like a normal diode symbol. And the second one is Zener Diode, which look like the line which reverse here, named as Zener Diode here. And the third one, which is the last one, is we will cover Schottky diode, and the symbol look like this, which is like Z in inverse direction. This is just a working of simple for the diode. Principle for the diode basically consists of PN junction, is shown in the diagram. PN junction, and we got a barrier in the middle where the current flow in one direction. Basically, the middle part also known as depletion region, and the doping process was occur in the simple diode there, which is PN junction diode, and the impurity was added in the middle of depletion region as well, and we got the forward bias for the diode. Here we got some example of the through hole diode, which is through hole component diode. The looks of the diode may come in various shapes and forms, as you can see in the diagram. Some even look like a buzzer, and some as well as even look like a transistor, just with the two legs. And some even look like a wheel. Now surface mount component will be more used, because in the future will be replaced. Through hole component will be replaced with surface mount. As you can see, here are several types of diode in surface mount. This just consists of two legs, come in various form but same in size, which in rectangular. Here is the Zener diode. Consists of reverse breakdown region, high reverse voltage, and heavily doped with impurity. As for Zener diode, current can flow at the forward direction as it can flow at opposite direction, as shown in the diagram, which the current can flow at forward current, and we got a reverse current as well. Here are the Schottky diode, which consists basically, as you know, Schottky diode have high current at high frequency. It is a hot carrier. It's a fast switching as well, and it dopes semiconductor region, which contains gold and silver or platinum as well. This is the Schottky diode symbol as we shown just now. It looks like a Z, but in much angle position. It got a low forward voltage drop with 0.3 volt to 0.5. So right here I could build a simple Zener diode schematic for me to much more understand what's going on with the Zener diode. Basically, Zener diode is just act like a switch for the circuit. Somehow it's like a switch. So let's get through it. We learn about the schematic first, then we go to the small experiment over here. Okay, you can see here this circuit diagram right here is off state. We have a 3.5 volt battery here, and we got a 1 kilo ohm of resistor here, and we got a 4.7 volt voltage drop for the Zener diode here, right here. So what happening here is the Zener diode is in reverse direction, right? Which it pointed over here, which pointed up here in this direction. So what happened here is, using the 3.5 volt battery, when the current flow through the circuit, through the resistor and the Zener diode as well, this is the Zener diode is the voltage drop is around 4.7 volt. In this case, this circuit cannot turn on because the battery is only 3.5 volt, whereas the Zener diode voltage drop is 4.7 volt. So somehow the Zener diode does not allow the current flow through the circuit. So this circuit is in off state. So what I explaining here is the Zener diode is just act like a switch. If it is more than 4.7 volt, it will let the current flow through the circuit. If it's less than 4.7 volt, the current will not flow through the circuit. Okay, let's see the on state. Here is the Zener diode in on state mode. Right now I got 9 volt battery here, and I got 1 kilo ohm of resistor here, and 4.7 voltage drop for the Zener diode here. And this time the Zener diode is in reverse direction. I place it in reverse direction. So what happened here is 9 volt battery supply to the 1 kilo ohm resistor, and the current is flow through the 1 kilo ohm resistor and the Zener diode, which is 4.7 volt voltage drop here, back to the battery here. So what happened here is 9 volt is more than the 4.7 volt of Zener diode in reverse direction. So somehow this Zener diode, this circuit is turned on because 9 volt battery is more than 4.7 volt of Zener diode. So by using this formula, let's say we want to find the voltage at the resistor here, how much voltage is on the resistor here. So we're using the V equals to IR. Voltage is 4.3 volt, which we know is for the resistor here. 9 volt minus 4.7 Zener diode voltage, then we can get the 4.3 voltage flow across the resistor here. So V equals to IR. V is 4.3 equals to I current, and R is 1000, which is 1 kilo ohm. So we just divide 4.3 over 1000, then we can get 0.0043, which is 4.3 milliampere flowing through the circuit. Okay, it's simple that the Zener diode is less than the battery, so the circuit is turned on. If the Zener diode is more voltage than the battery, then the circuit is turned off. It's just simple analogy here. So let's get through the experiment, which to prove it, is it our theory is correct. So somehow I'm here is have to prove it. Is it true our theory based on the small mini experiment we have to done over here. So let's together we do the experiment here. Okay, alright. Somehow here we prove it our mini experiment here with 9 volt battery, resistor, 1k resistor, and a Zener diode here, right? And we're using a multimeter to troubleshoot the circuit as well. Alright, so right here, okay, 9 volt battery, just power it on, go to the positive rail. Another one is a negative rail here. Alright, so the circuit is somehow is turned on because it is in a closed circuit. The current will flow in a closed circuit. Alright, Okay, using the multimeter here. I'm switching to DC voltage. Here, DC. Okay, right here. This will be nice. We know that this is the battery is 9 volt battery. When flow to the resistor, we check how much is it. Okay, wrong direction. Make sure the polarity is correct. The leads is correct in the first. So it's 8.62 voltage at the resistor. And this Zener diode, I place it in the forward bias mode. So you can see the Zener diode right here is in forward bias. Alright. Because the black at the back and the red at the front. So it's moving, the current is moving here in forward bias mode. So red leads here, black leads here. So it's shown that an average diode which is showing 0.7 volt. Alright, the standard diode flowing in forward bias mode. Alright, so we done with it. Let's say we reverse the Zener diode, we act them as like a switch. Somehow this Zener diode, which is I think the model is PH414, some sort of like that. So it's yeah, it is PH4148. So it is high voltage, high reverse voltage diode, reverse voltage Zener diode. So let's say I place it in the reverse direction. High reverse voltage diode, high reverse voltage Zener diode. Alright. Okay, I place it in the reverse direction. Somehow I put it in the DC volt. Alright. So the resistor is 0 volt here. Somehow all the voltage is gone through the diode, I guess. It's showing that 9.76 at the diode, which is the reverse bias mode. So somehow the experiment showed is true and related to the theory part. And sometimes it gets it depends on the diode application, how it handles the current and the voltage. Alright, that's all for me. Don't forget to like, share and subscribe. We'll see you in the next video. Bye.